Hi everyone, welcome to today's math lesson. Today all of our lessons are going to be on page 9. We're going to start with an entrance task here of solving these are called quadratic equations when they have a squared term in it. Alright, you don't really need to know that for now. But you're going to get the variable alone by using algebra here. Remember that you first want to get the squared term alone if it's not already. Most of them they already are isolated the squared terms, but number 4 and 6 you'd have to get rid of the 10 and the minus 6 first. So go ahead and pause the video and try these. They shouldn't take very long, just to build off of what we did yesterday, and then we'll be taking notes on what we call the cube roots after this. Okay, so now let's go ahead and take solve each one of these equations. We'll start by the only thing bothering the x here is this exponent of 2 to the square, so we need to get rid of it. The opposite of squaring is square rooting, so I take the square root of both sides. Square root of x squared is x. The square root of 169 is 13. And whenever we do a square root of an algebra problem, we have to do plus or minus sign. It could be positive or negative 13. Okay. Number 2, y squared equals 49 over 64. Alright, again, the only thing bothering the y is the square, the exponent of 2, so the opposite of squaring is square rooting. And when we square root a fraction, you can think of it as the square root of the numerator divided by the square root of the denominator. So the square root of 49 is 7, the square root of 64 is 8, and we're going to have our plus or minus sign, so it's plus or minus 7/8 for our answer there for number 2. Number 3, the variable's on the right hand side, no different, I just need to get it alone, so I got to get rid of the exponent of 2, square, so I'm going to square root both sides. Square root of 196 is 14, it's going to be plus or minus 14. Okay, now number 4, before I'm going to go ahead and take the square root, I'm going to first isolate the squared variable here, so I'm going to get rid of this plus 10 first. So I start by doing an algebra step of subtracting 10 both sides, leaving me with x squared equals 9. Now I'll take the square root of both sides. We get x equals plus or minus 3. W squared equals 1/4. So again, we just take the square root here. Square root of 1 is 1. Square root of 4 is 2. So this would be plus or minus 1/2. And finally, number 6, I gotta first get rid of this minus 6, so I'm gonna add 6 both sides. Y squared equals 36, square root, y equals plus or minus 6. Now, all these answers came out pretty nice. If you have a number that, I'll say this again, I said this in one of the other videos from last week, if you have a number like the square root of 10, it's going to be approximately like 3.1, but it's going to be what we call an irrational number. Okay, in other words, if you put square root of 10 into a calculator, you're going to get this long decimal that goes on forever without repeating. It's just kind of like pi. There's no pattern to it, it just goes on forever without repeating. That's called an irrational number. And if you have a square root with that doesn't come out perfectly, it'll have to tell you one of two things. It can say leave it in radical form. Radical form would be just like this. This would be square root of 10. You would just leave your answer as square root of 10, or sometimes referred to as radical 10. Or it'll tell you to round to something. So this would be like the answer rounded to the nearest tenth. Okay? So it doesn't mean you necessarily got it wrong if one of them comes out to be not perfect as far as something like that goes. Okay? And remember, for plus and minus, I'll just take number 4 here for example. Okay? The reason we can say that x squared plus 10 equals 19, again, you can check a problem with both the positive and the negative answers to show you that it works. So if I checked x squared plus 10 equals 19, and I first plugged in 3, obviously 3 will work. you get 9 plus 10 equals 19, which sure enough, 19 equals 19. Check. Okay. But the negative answer will work too, because of the fact that a negative times a negative gives you back a positive. So if I plug in -3 for x, when I square it here, can't quite see it there, sorry. -3 squared, well, -3 times -3, you remember that negative times a negative is a positive. If you don't believe me, you can type it into your calculator. And you still get 19 equals 19. So indeed, both 3 and -3 really do make that equation true when you check it here. So that is for squares. Now today we're going to be talking about cubing, okay? And when we cube, we're talking about a number multiplied by itself 3 times, okay? And just so you guys know, it says right here, you don't need a plus or minus sign when you're taking a cube root of an equation. And the reason is when you cube something, it's times itself 3 times. So one of the basic ones is that you'll learn is, okay, since the 2 cubed, or 2 to the 3rd power, is 8, right? Because 2 times 2 times 2 is 8. 2 times 2 is 4, and 4 times 2 is 8, right? So going the other way around, this is what a cubed root looks like. Put a little 3 on that little line right there. The cubed root of 8 is 2. Again, for the same reason that when you multiply 2 by itself 3 times, you get 8. But notice that you cannot say the cubed root of 8 is never going to be equal to, that's a not equal to -2. And the reason is, if you try to multiply -2 times -2 times -2, you end up getting negative times a negative. This would be +4. And then +4 times -2 is -8. So it gives you back a negative, not a positive like you wanted, right? So you don't need the plus or minus signs, okay? If you read the notes here, it says, if what we learned already is that squaring and taking the square root of are inverse operations, they are opposites of each other, then cubing and taking the cube root are inverse operations. And again, this is how you show algebraically taking the cube root, all right? Here are the first 5 perfect cubes listed here. Why are these the first 3 perfect cubes? Well, 1 times itself 3 times is 1. 2 times itself 3 times is 2, or 2 cubed. 3 cubed, or 3 times itself 3 times is 27, right? 3 times 3 is 9, and then 9 times 3 is 27. 4 cubed is 64. 4 times 4 is 16. 16 times 4 is 64. And then 5 cubed is 125. So I'll keep the numbers pretty small as far as cube roots. You can do them on your calculator too. It's a little bit harder. If you have a calculator button for it, it can look a few different ways. See if I can show you on my phone here. You have to go to the scientific one on my phone, and oh, it doesn't look like it has it on my phone here. For it, they have the square root symbol like this on my phone, okay? Which is another reason why I'll keep them really simple. It has it on my computer, but I don't see it on my phone here. If it had a little X right there above the sign, then you could type in 3 and then that root, and that would be like the 3rd root to do something like that. Alright, so that would be a little bit another way you could do this. Alright, so here's your examples. Again, I'm only going to give you the real easy ones for cube roots, one of these first 5 ones. Alright, so if I have x to the 3rd power, or x cubed, I would get rid of the exponent of 3 by taking the cubed root of both sides, so it's like the square root with a little 3, and it's x equals 4, not plus or minus 4, just 4. Why? The reason is you're thinking, what number when you cube it gives you 64? Well, that's 4. 4 times 4 times 4. So again, you just kind of got to remember these numbers up here to help you. Alright? Here's one for you to try. You can pause it and try real quick. Okay? So hopefully you did this one. You first would start just like before and subtract 5 both sides. You get x cubed equals 27. The opposite of cubing x is to take the cubed root, so it's going to be the 3 with the root, 3 with the root here. Okay, so it's the cubed root. they're opposites, so the cubed root of a cube gets rid of the cube. You get just left with x here. And what number, when you cube it, gives you 27? That was 3. 3 cubed gives me 27. So my answer is just 3. Okay? So go ahead and try page 10 after this. On page 10, you have a couple of cubed problems. I think 3 cubed problems and then 3 squared problems. So you're doing a little bit of cube roots and square roots. Okay? Good luck. Thanks for tuning in, and I'll check in with you guys tomorrow. Have a great day.